My name is Jim Strand. My role here in Oliasoft is I'm head of product, and my background is drilling engineering from different operator companies. I'll do a mix of presentation and just showing you in the application here. So the product strategy in Oliasoft is we have this main product, Oliasoft WellDesign. You know the legacy systems, right? There's multiple products that covers a value chain of engineering capabilities, ranging from trajectory, anti-collision, tubular design, drilling mechanics, blowout and kill, and so on. And the purpose for the WellDesign tool is to have all of that in one engineering package. And of course, the differentiator here, the reason why a lot of operators are now switching to this system is because of its modern architecture and the fact that we can easily integrate with other systems in either way of the value chain. This product is now well validated. So we've had huge validation programs with a lot of large operators, Equinor and Shell and companies like that. So what we're doing now is we are expanding the product portfolio in both ends of the sort of downstream of what we do and upstream of what we do. And we are also deepening the capabilities within the WellDesign package. We have something in WellDesign here called kick tolerance. This is a single bubble model, equivalent to the Excel sheet that a lot of oil companies are using. It's slightly more accurate than the Excel sheets because we are integrating over the open hole area instead of just calculating at TD and at the casing shoe. So you would get slightly higher kick tolerances using this than the Excel sheet, but it's still not a full multi-phase model. So what's the plan for that? Yeah, so let me just have a few words around this thermal model then. And one of our neighbors here to our office in Oslo is IFE, Institute for Energy Technique. They were the ones that created Olga. And we have the four same scientists that created Olga has created this model. So I will just mention a few words about this. We call it a thermal simulator, but it is much more than that. It's actually a fully fledged multi-phase finite volume grid simulator. So what it means, it's the same as Olga. It's just not made for pipeline flow. It's made for wells. So it calculates the accurate PVT properties of the fluid, the phase envelopes, the gas properties, and the oil properties, and the solubility, and all of that. And we have a number of multi-phase models that we are using to calculate the accurate behavior of the fluid that comes up. So this is naturally can be used for a lot more than calculating temperatures. So we are using this same engine in our blowouting dynamic kill module. Yeah, so the dynamic kill module is very advanced. In there, you can simulate a full blowout in a blowing well, and then you can, for example, have a relief well where you pump in kill mud. So in the product pipeline is a full well control module, but for the time being, what we have focused on is to be able to fulfill all of the authority requirements, especially for NORSOK D10 here in Norway, but also internationally, so BESI requirements and so on. So tubular design, for example, in Oliasoft is very similar to something like WellCat, right? So you will go in and define lots of load cases, and you would do some thermal simulations and link those into load cases and so on. All of that stuff is quite labor intensive. It takes a long time just to define all of the loads, right? But all of this is standard. So we have what we call rule sets, where customers can just apply all of the loads with the rules that they have in their internal technical requirements or whatever. But we also have a fully automated WellDesign capability. So we call that rule-based design. So I'll just demo it very quickly. So here I have a project which has no casings in it. It has no loads in it, but I do have a pour and frac prognosis, and I do have a trajectory. So what I can do is to enable this automated design module, I can apply some rule set to this data set, and I can just do this automatically based on some rules. So it will calculate the setting depths based on my criteria. It might be based on some formation or kick tolerance or whatever. Rules for cement heights, rules for mud weights, and so on. It will calculate all of the loads and do my material selection and so on. So the point with this is that, yes, we can automate the well design based on certain criteria. But what you want to do, I'll just finish this up. Now I have a well with a bunch of sections. This was a deep water example. All of the loads in all of the sections have been defined and so on. What you want to do is not just to automate one design, right? Because there is infinitely many designs that potentially could still fulfill your rule set, right? Mm-hmm. So what you want to do, you want to design maybe hundreds or maybe thousands of these automated designs, but all of them would fulfill your rule sets, right? And you would optimize it on something. So at the moment, if we don't have a time and cost module, we can only optimize on certain engineering parameters like safety factors or whatever. But it doesn't make sense to optimize on safety factor because you would just end up with a really robust design. What you do want to optimize on is something like time or costs, right?